with zero level at A. Zero level at A, huh? So A is 0. So again, I try to calculate the potential energy at A and the potential energy at B, and I find the difference in the potential energy, right? So calculate the potential energy at A. Oh, 0. The potential energy at A is 0 because now the 0 level is at A. So 60 times 9.8 times 0. The vertical displacement is 0. Okay, now I try to calculate the potential energy at B. Potential energy at B is mgy. M is 60, G is 9.8, but Y is -10 because it is below the 0 level, 10 meters below the 0 level. So it's -10. Now when I multiply all this together, I get potential energy at B is negative 5,580 joule. Negative. Then again, I try to calculate the change in potential energy. So I use the final potential energy, negative 5880, minus the initial potential energy, which is 0. I get the same answer, negative 5880. So this example shows us that it is independent of the reference point. It is independent of the 0 point. No matter where you take the 0 point to be, the difference in energy is the same. Now, you can even put the reference point, the 0 point at C. So if the 0 point is at C, the potential at A is, the height is 8. If it is at C, then the potential at B is -2, right? So we're going to use this set of numbers, 8 and -2, to calculate again the potential energy at the 2 points, at point A and point B. Okay, so at point A, the potential energy is mgy. So 69.8 times 8. So it's 4,704 joule. And because it is above, so it is positive, right? Then we look at the B. The B is also mgy, 60 times 9.8 times -2, because it is below the point C, 2 meters below the point C, so it's -2. And we get the answer to be -1176 joule. Now the numbers, they are different. Not only they're different, one number is positive and one number is negative. Are we going to get the same answer? The difference in potential energy, are we going to get the same answer? Don't be afraid, right? We try to use the same method. The change in
Okay.
potential energy is the final potential energy at B minus the initial potential energy at A. Okay. The final potential energy at B is -1176 minus the initial potential energy at A is minus a positive number, 4704. And it works out to be -5880 also, right? So that's why this whole example is trying to show you the difference in potential energy, the change in potential energy is always the same, irrespective of which 0 level you are taking. Next. You read question 5.4.
If the zero level for gravitation, type of one, if the angle of the slope is increased, what does the change in gravitational potential energy between two heights increase, decrease, or remain the same?
Okay. Now the vertical height remains the same. The vertical height is 10 meters, 10 meters, and 10 meters. Let's say we have three separate cases. Let's say we have three. Here, the question they didn't tell us. They just tell us you can actually change the inclination of the slope. But I'm going to list out three cases here. One not so steep, another one steeper, and finally there's one very steep. But the height, the vertical height of the inclined plane or the slope is always 10 meters. Now the question now is that let's say if one person is slide down the slope from the top to the bottom,
Okay.
from the top to the bottom, from the top to the bottom with three different types of inclination. Then they ask, hey, the change in potential energy, is it the same from the top level until the bottom level here? Is it the same? So the answer is yes, they are all the same. The change in potential energy only depends on the vertical height. Only depends on the vertical height. If the vertical height is the same, then the change in potential energy is the same, right?
Okay.
Okay. Next one, you read 5.4, exercise 5.4.
If the zero level for gravitational potential energy is selected to be midway down the slope 5 meters above point B, find the initial potential energy, the final potential energy, and the change in potential energy as the sphere goes from point A to B in figure 5.15.
Okay, let's say I hide all the answers, the working. So can you tell me how much is the potential energy at the point A, at the point B? How much is the potential energy at A, at B? And how much is the difference in potential energy if I take the center point here as the 0 point? If I take the center here as 0, right? So that means the point A is positive 5, the point B will be negative 5 meters. So can you calculate the potential energy? Let's say I copy this. Let's see I'm until here lah. Okay, I copy, edit, copy, and move back here. Then I paste here so that you can refer to this. Okay, so now the numbers, they all change already, the numbers here all change.
Yep.
So can you tell me what is the potential energy at A if we use the center point to be 0? So what is the potential energy at A? Can you calculate the
Uh,
potential energy at A? Use the formula mgy.
so
M is
60
same lah, 60 lah. M is 60.
times
G,
9.8
then how much is the Y?
times 5,
Correct, correct,
2,940 joules.
correct.
So
Okay,
it will be 2.94.
okay. So now the next one. I want you to calculate the potential energy at B.
That will be the same, but you negative instead.
Okay, correct. Then how much is the change in potential energy? You must use the final minus the initial, not the initial minus the final. So
Yeah,
what are
so
the two numbers?
negative 2,945 minus 2,940. So it will be negative 5.88.
Correct, correct. So you know how to do this, right? So I
Yes,
can move on to the next one. Move on to the next one. Okay, right.